In order to be able to take advantage of the master equation for mechanical energy, you have to know the potential energy functions for different types of potential energy. So let's start off with gravitational potential energy. The basic function is this: the change in gravitational potential energy is equal to the mass times the acceleration due to gravity times the change in the height. Now, that delta kind of confuses some people, but this is really the only true statement that potential energy always depends on where you set your 0 point. So this is generally true, but what is easier is just to say that UG equals mgh, but you must set your point where h equals 0. And then you can say, okay, compared to that point, this is the gravitational potential energy. Notice it could be positive or negative. If you're above h equals 0, you got positive gravitational potential energy. If you're below h equals 0, it's got negative gravitational potential energy. The other type of potential energy that we're typically dealing with is spring potential energy, U sub s. And that is actually going to be equal to 1/2 k, the spring constant, times x squared. Don't confuse this equation with Hooke's law. Hooke's law, which this is based on, is that the force exerted by a spring is equal to negative kx. That is not the same thing. This is like the fundamental equation, and we can derive this potential energy equation from it. In this equation, x is the amount of stretch of the spring from the equilibrium point. Stretch or compression. So I'm going to put compression or stretch from the equilibrium point. When you do this, and this is the way I'm going to recommend that you do it, you must set x equals 0 as the u spring equals 0 point. That's the only way that works. You could actually set the potential energy point equal to 0 anywhere in that spring stretch or compression, but then you'd get negative potential energies, which can be very confusing. So let's just go with this, but make sure that you set h equal to 0 somewhere, and let's go with this, but make sure that you set x equals 0 as the spring potential energy point.